Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2010 question 2, this was before Project Maths, but of course the course Maths is still Maths, it hasn't changed that much. Question 2a, find the area of the triangle with vertices 0, 0, 8, minus 6 and minus 1, 5. Vertices being another word for corners. Okay, so find the area. So what you're doing is you are going to your log tables, page 18, and you're using the area of a triangle formula. So half of x1, y2 minus x2, y1. Okay, you just be careful when you're using this formula because it only has 2 points in it, x1 and y1, x2 and y2. You have to be careful that one of your points is at 0, 0. And if it's not, you have to do a translation of the points to ensure that they are at 0, 0. So x1, y1, x2, y2. And if you're unsure how to label your points, it's here in the log tables. So then sub them in. So you have half of x1, which is 8, y2 is 5. You can see I didn't take the 0, 0 point. You don't use that one, you use the other two. So x2 is minus 1, y1 is minus 6. Let me just check I have that right. So x1, y2, yes, by minus 1 by minus 6. Okay, and I'm going to put that into my calculator. So I'm getting a half of 8 5s are 40 minus, so I'm getting half of 34, so 17 units squared. Okay, so that's area. The two lines down the side mean the absolute number, or you always take the positive. So if I'd got a negative area here, my answer would still be positive. So part B, L is the line 3x minus 4y minus 15 is equal to 0. Verify that 1 minus 3 is a point on the line. Okay. So if this point is on this line, then we say the point satisfies the line. Okay, so I would label the point x and y. I don't really need the ones in this case because I don't have 2 points. So it's just x and y. And you sub them in here so that he becomes, I'll do it up here. So this is B part 1. I have 3x minus 4y minus 15 is equal to 0. Sub in my points. My x value is 1. My y value is minus 3, minus 15 is equal to 0. Okay, so that becomes 3, minus by minus is a plus, it's 12, minus 15 is equal to 0. So I'm getting 0 is equal to 0. The left is equal to the right of that equation, so therefore the point is on the line. Okay, and that's all you do for that one. If you didn't get the left equal to the right, you would have made a mistake because that word verify means prove or show. Okay, so they're telling you that that point is on the line. So the left will equal the right, otherwise you've made some sort of a mistake. L intersects the x-axis at P. Okay, so we've done a few of these in other videos. So we write down at the x-axis, my y coordinate is always 0. Okay, so I again take the equation of that line and I sub in the y coordinate being 0 and I solve it for x. So 3x minus 4 times 0 minus 15 is equal to 0. Well, anything by 0 is 0, so that just disappears. So I have 3x, I'll bring the minus 15 over and it'll become plus 15, divide by the number in front of x. So x is equal to 5. Okay, so I was told to find their coordinates. So x, comma, y. Okay, the line K passes through the point 1 minus 3 and is perpendicular to L. Show the lines L and K on a coordinate diagram. Okay, now let's see how well I can draw these on the screen. I shall try. Okay, so 1, 2, 3, 4, 5. Zoom in a bit. 6, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay, and I'm making sure I go up and down by the same amount. In other words, the widths between the numbers are the same. And this point here is my origin. It's 0, 0. Okay, so to plot any line, you need 2 points. So what information do I have? Well, L is the line that verify that 1 minus 3 is on the line. Okay, which means that 1 minus 3 is on that line. So there's 1 down to minus 3. So I'm just making it a bit big so you can see it. So over to 1, down to minus 3. So it's that point there. So that's that point. And the other point I had on L intersects the x-axis at P, find the coordinate of P. So 5, 0 must be on that line as well. Okay, so let's attempt to draw that one. Didn't work. Okay, not too bad. Little bit out. You can see it down the bottom. Give it one more try, will we? Okay, that'll do. Okay, so that's the line L. Okay, then to draw the line K, I have a couple of options. I could find where it cuts through the x-axis, just like I did here with L. I could find where it cuts through the y-axis, and you do that by letting the x-coordinate equal to 0. It's always the opposite coordinate. But I don't need to, because they've told me that the line K passes through the point 1 minus 3. Ah, okay, it's passing through the same point. Okay, so the line K also passes through this point and it's perpendicular. Okay, so if I had my math set and if I had the triangles in it, you can use the triangles to perfectly draw a line that is perpendicular to this one, but it comes at it at a 90-degree angle, so that's why the triangles would be handy to be able to draw that line, and that is the line K. Okay, so if you have a point on the line, just like we had, the 1 minus 3, and with the fact that it's 90 degrees or perpendicular to line L, you should be able to draw it. Okay, find the equation of K. So to find the equation of K, the equation of a line formula is y minus y1 equal to m times x minus x1. So we get that from our log tables as such. Okay, that top one is what we use to find an equation. This one, when we're given an equation, and normally we need to get the slope from it. So to use this equation, I need a point on the line x1, y1, and I need a slope m. Okay, I have a point on the line. They've given me 1 minus 3. So that's good, 1 minus 3. So that's going to be my x1, y1, and I need slope. Okay, I need slope. Right, so I either need 2 points on K, or I need to find the slope of the line L, and then turn that slope upside down and change the sign, because that's how I get the slope of the line perpendicular to it. So there's a couple of ways I could do it. I could use y is equal to mx plus c up here. And if you're okay, it's on the recording. I'm going to delete off these down here because I'd rather show you how to do the two ways of finding the slope. Okay, so finding the slope of L, okay? And I have to find L because I don't have a second point on K, or I don't have the equation of K to find the slope. So slope, again, I'm using the slope formula from the log tables. You can see how good the log tables is for this section. Minus x1. My points that I know on that line are 5 and 0, x1, y1, and 1 minus 3, x1, y1. Okay, so x2, y2. So slope minus 3, y2 minus y1 over x2 minus x1. And if I put that into my calculator, I get minus 3 on the top and minus 4 on the bottom, so 3/4. Okay, so that's the slope of L. Okay, or I could have used y is equal to mx plus c to find the slope. So how would I do that? Well, you take the equation of L and you write it in this order. So y's, so minus 4y, okay, then it wants the equals to sign. Then it wants the x's. Now they're on the left of my equal to sign, so I need to bring them over to the right. And the plus 3x will change to minus 3x. And you can see then the plus c is the number. It's also on the right of the equals to sign. This is currently on the left, so I have to bring him over, and he's going to become plus 15. Okay, now I want a positive y, so let's change the signs all the way across. And then it's a single y that's here, so we need to divide across by the number in front of y so that I get a single y here equals 3/4 x minus 15 over 4. Okay, and this m that's here in y is equal to m plus c is the same m that's here, it's the slope. Okay, so that is also how you could have found the slope of L. Okay, and then the relationship between slopes and perpendicular lines, if m of L is equal to 3/4, then the slope of K is equal to, we'll turn 3/4 upside down, so it becomes 4 over 3 and change the sign. So it's minus 4 over 3. Okay, and then I sub it into this formula here so that we get y, using my point, minus y1 is equal to minus 4 over 3 times x minus x1. That's my x1. We don't sub in for x and y. We're generating to copy that onto a new page just to give us a bit of room. That's part C. Get rid of it yet. It doesn't want to go. It's too happy where it is. Definitely doesn't want to go, does it? Okay, well, we'll ignore it. Okay, so y minus minus 3 becomes y plus 3. It's gone now. Is equal to minus 4 over 3 times x minus 1. Okay, so all I did there was tidy up these signs to become plus 3. Okay, when you have a fraction here, that 3 comes over here. Okay, so it becomes 3 by everything on the left is equal to the top one stays where it is, like so. Okay, what did I do mathematically? Well, I multiplied by the number on the bottom, multiplied both sides by 3 so that the 3 there cancelled. Okay, or you can remember it, bring the bottom one up. And then multiply. So 3y plus 9 equals minus 4x minus by minus plus 4. Bring over the 9. 3y is equal to minus 4x plus 4 minus 9 would give me minus 5. Okay, and that is the equation of k. Okay, so the hardest part of that, I think, was finding this slope so that you could turn it upside down and change the sign to find the equation of k. Okay, A is 2 minus 1, B is minus 4, 7 are 2 points. Find this. Okay, now this is very important and I'm delighted to see it here so that I can explain it. That is maths language for the length of. If you come to the same page, same formula page, you'll see here the two lines, the length of PQ. So you have to know when you see that, that means the length of, and that you use this formula here. So the length of AB is the square root of x2 minus x1, all to be squared, plus y2 minus y1, all to be squared. Okay, if these are the 2 points I'm finding the distance between, that's x1, y1, x2, y2. xy of my first point, xy of my second point, and you sub them in. So x2 is minus 4, x1 is 2, all to be squared, plus y2 minus y1, all to be squared. So you can see the minus number there, the y1 just popped into a bracket. Hit the square root sign, bracket, minus 4 minus 2, all to be squared. I'm just putting it into the calculator, plus bracket 7 minus minus 1 squared, and I'm getting the length of AB is equal to 10, a nice even 10. Okay, find C, the image of B under the translation 2 minus 1 minus 7, 11. So not so much the coordinate geometry chapter anymore. This is translations and enlargements, and it can come under geometry. So C is going to, we want to find the image of B under the translation 2 minus 1 minus 1, 7, and we're calling it C. So we have to first figure out what is the translation. Okay, so we have 2 minus 1, 2 minus 7, 11. So to translate something means to shift it or move it. So you have to figure out how much did you move it by. Well, let's have a look at our x value. So I'm comparing x value in this one with x value in this one. I'm going, right, well, how much did that move by? So how much, if I was to go from number 2 on a number line, that's 2, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So if I was to go from 2 on a number line all the way to minus 7, how far would I go? Okay, and you're going back 9 steps. Okay, and your y then, I'm going from minus 1 here all the way up to 11. And so for your y, you're adding on 12. Okay, and if that doesn't make sense, draw out the number lines properly and just show yourself that it's the same. So that's the translation. That's how much we're moving by. Minus 9 in the x coordinate, plus 12 in the y. So when it says find C, the image of B, well then B is the one that we're going to move by that amount. So B is minus 4, 7. I got that from here. Okay, and we're going to move it. So in other words, we're going to subtract 9 off the x, and we're going to add 12 to the y to give me the new point that they're calling C. So minus 4 minus 9 is minus 13, 7 and 12 is 19. So C is the point, minus 13, 19. Okay. Show that the length of AB is to the length of AC is equal to 2:5. Okay, so a ratio. So you know what the length of AB is. It's 10. Okay, let's find the length of AC because we don't know that yet, so we can't compare them. We can't see if they fit that ratio until we find the length of AC. Okay, and it's the same formula. It's the distance of a line. So x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, except the points this time we're doing are A, which is 2 minus 1. So that's my x1, y1, and C, which is the point minus 13, 19, is x2, y2. So let's sub them in to find the length of AC. It's the square root of x2 minus x1 squared plus, I did that the wrong way around. Now let me do it right this time. So x2 is minus 13 minus x1 squared plus y2 minus 1 squared. Okay, and into a calculator with that. Squared plus y2 minus y1 squared. And I am getting 25 for the length of that. Okay, so if you're okay, I'll come over here to finish part 3. Okay, it tells me to go the length of AB is to the length of AC. Now you might not know what that means properly, but write down what they have, write down the lengths that you find and figure out, is that the same as a ratio of 2:5? Okay, well, if I simplify these or write them in their simplest form, can you see that I can divide across by 5? So he is 2:5.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.